Hello and welcome to this video on covalent bonding. Now, we've talked in a previous video the fact that elements can fill their outer energy levels in two ways. In so doing, they become stable. And they can do this either by gaining or losing electrons or by sharing electrons. Now, we've got some technical terms for these. For gaining or losing electrons, we've got what's called ionic bonding. And for sharing electrons, that's called covalent bonding. Just to recap on what we did in the previous video on ionic bonding, here's what happens. Okay, so only the group 8 or group 0 elements are stable with full outer shells or orbits. To become stable, all other elements need to lose or gain electrons from the outer shells. All metals lose electrons and so become positively charged, and we call them ions. All non-metals gain electrons, so become negatively charged, and as you say, they're called ions. The positive and negative ions attract each other and so form what we call ionic bonds. Okay, let's focus now not on ionic bonding but on covalent bonding. Okay, these are two really key points. First of all, covalent bonds form between non-metal atoms. You never get covalent bonds between metals and non-metals. It's always between non-metals. Also, covalent bonds involve the sharing a pair of electrons. So rather than transferring electrons from one to the other, they simply share. Okay, so two key points. Covalent bonds form between non-metal atoms, and covalent bonds involve sharing a pair of electrons. Let's have a look now at some examples. I've got 3 examples for you. Here's the first one, and it involves hydrogen. Now, hydrogen atoms only have one energy level or orbit, and in that orbit they've got one electron. Now, in order to be stable, they've got to gain a second electron and so become stable. Now, what happens is two hydrogen atoms share electrons. So this one here has got 1, 2 in its outer shell. This one here has got 1, 2 outer shell, and that's achieved by sharing. So both hydrogen atoms share electrons, so they are stable. And what we've got a hydrogen molecule. H2 has now been formed. Another example, this is ammonia, okay, NH3 ammonia. Now, in this example, each hydrogen atom, as we saw previously, requires one electron in order for the outer orbits to become full, and so they become stable. Now, nitrogen is in group 5. Now, nitrogen requires how many electrons? 3 electrons to fill its outermost shell. At the moment, it's got 5 there. 1, 2, 3, 4, 5. It needs another 3. So what it does, it gains an electron to share with each hydrogen. So there is a covalent bond. So that hydrogen's got 2 electrons. It's happy. Here's another hydrogen over here. Again, sharing, covalent bond. And the third one here, again, sharing. So nitrogen has got this lone pair, call this a lone pair of electrons here. They're not involved in bonding at all. It's got 1, 2, 3, 4, 5, 6, 7, 8. Okay? There are now 3 pairs of electrons shared between nitrogen and hydrogen, what are called nitrogen-hydrogen bonds. 3 covalent bonds have been formed, which means that the outer energy levels or orbits of nitrogen and the 3 hydrogens are now full. They're stable. One more example. This is water. There we go, pretty simple. Now, the formation of water, H2O, the oxygen atoms require 2 electrons. Oxygen is in group 6, so it's got 1, 2, 3, 4, 5, 6 electrons out of the shell. It needs 2 more to become stable. As we know, hydrogens require to fill the outer one there with another one. So each hydrogen requires 1. The oxygen here requires 2. So surprise, surprise, what happens is each hydrogen shares with oxygen. So there's a covalent bond there, there's a covalent bond there, and oxygen happens to have 2 lone pairs of electrons, 1 pair there, 1 pair there. So now we've got 1, 2, 3, 4, 5, a shared one 6, another shared one 7, 8. And also both hydrogens are happy. So in the formation of water molecule, 2 covalent bonds, OH, link the oxygen with the hydrogen atoms. I hope that makes sense to you. If not, go back and look through those again. Now, we can display covalent bonding in several ways. First of all, we've got what's called dot and cross. This is quite a famous way of showing it, dot and cross. Here we display electrons of one element, here oxygen, as dots, and the other one, hydrogen, as crosses. So we represent the hydrogen electrons as crosses, the oxygen electrons as dots. So 1, 2, 3, 4, 5, 6, 7, 8. That's a dot and cross diagram. Another way to show dot and cross, but let's not bother with all the circular orbits. I can't draw circles, so I prefer this way. Okay, we don't have to draw the orbits in these diagrams. We just need to make sure we get the dots and crosses in the right place. So oxygen has got 1, 2, 3, 4, 5, 6, 7, 8. And there's a covalent bond, and there's a covalent bond. So hydrogen's got a covalent bond there, and one there. That's a simple way of showing it. An altogether simpler way is what we call displayed formula. Now, this is the simplest way for showing the bonds that make up a molecule. Covalent bonds are shown as single lines. So here we've got 2 single covalent bonds. We call these OH bonds. So one there, one there. Couldn't get simpler, could it? So to summarise, we've got 3 ways of displaying covalent bonding. We've got dot and cross like the orbits, and displayed formula. Now hopefully you now understand how to draw covalent bonding between atoms. So use dot and cross method, whichever one you prefer, display covalent bonding in the following molecules. These are all covalently bonded molecules: chlorine, hydrogen chloride, methane, oxygen, nitrogen, carbon dioxide, ethane, ethene. Now have a go at a couple. You don't need to have a go at all of them. Just try 1 or 2. Okay? Right. Now, as with ionic bonding, when we had giant ionic structures, we've also got giant covalent structures. Here's a very famous one. This is diamond. Now, diamond's a form of carbon. Carbon's in group 4. It only ever forms covalent bonds. A giant lattice structure where each carbon atom forms 4 covalent bonds with their carbon atoms. Large number of covalent bonds results in a diamond, which has a very, very high melting point. One of the strongest substances known to us. Diamond, very high melting point because it's got 4 strong covalent bonds between the carbon atoms. Now, graphite is another form of carbon, and it's got a giant lattice structure in which each carbon atom forms 3 covalent bonds with other carbon atoms in a layered structure in which the layers slide past each other. There are weak forces of attraction between layers, and you won't realise it, but you use this every day when you use a pencil. Now, pencil is made of graphite, and this is a graphite molecule here. When you're writing with a pencil, you're literally rubbing off layers of the graphite onto a page of paper, and that's how you draw. Now, electrons are free to move between layers, so graphite is a jolly good conductor of electricity. In fact, it's the only non-metal that does that. Now, let's compare the properties of ionic and covalent compounds. In the left-hand column of the table, we've got ionic, right-hand column, we've got covalent. So ionic are usually solid at room temperature, whereas covalent are usually liquid or gas at room temperature. Why is that? Well, between the ionic compounds, there are strong attractive forces, so it retains this solid structure. Now, in covalency, within the molecule, between oxygen and hydrogen, between carbon and hydrogen, what we're looking at, there are strong intramolecular forces, but between molecules, we call them intermolecular forces. The forces are pretty weak, therefore they're usually liquid or gas at room temperature. So, ionic, usually high melting and boiling points, usually low melting and boiling points for covalent, for exactly the reasons I expressed. Ionic usually solid in water, the ions dissociate in water, whereas covalents usually insoluble in water. And lastly, ionics conduct electricity when molten or dissolved in water, whereas covalents do not conduct electricity, with the exception, as I said, of carbon. Alright, let's just summarise now, looking at covalent bonding. Here we go. Covalent bonds form between non-metal atoms. Covalent bonds involve sharing a pair of electrons. There are no ions formed in covalent bonding, no positive or negative charges between ions. The positively charged nuclei of the bonded atoms are attracted to the shared pair of electrons by what we call electrostatic forces, making covalent bonds very strong. As I said, within a molecule the bonds are very strong because these electrostatic forces between molecules, the electrostatic forces are pretty weak, which is why they're mostly liquids and gases. Okay, well that's it for covalent bonding. I hope you now understand covalent bonding. So thanks for watching and listening, and I'll be back with another video very soon. So bye bye for now.